Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 5 of the November daily LeetCode challenge and we again have a medium level question in front of us. Let's see what this question is. It's question 2914. Minimum number of changes to make binary string beautiful. Okay. So they are saying it's a binary string and there is something called beautiful and we have to see the definition of what it means. So we have to make the binary string beautiful. So we'll see the example first. Here, as you can see, the string is binary. Okay, the input will be a binary string. That is, the string will only have ones and zeros, and in the output, we'll have to return a number. Okay, it's an integer. Now let's see the question. You are given a zero indexed binary string as having an even length. Okay, one first property that we got is it's a binary string. Okay, other properties it should be of even length. Okay, these are like given, given thing to us. That is always the input will be like this only. Okay, a string is beautiful if it's possible to partition it into one or more substrings. Remember, they are saying one or more substrings. So I am assuming that you know what is the meaning of substring and how it is different from a subsequence. Okay, so you can think of like subsequence basically means you can take anything. They are like need not be neighbors of each other. Those elements need not be adjacent to each other. That is the meaning of subsequence. But here I am talking about substring. Okay, substring basically means you have to take a part of the array, that is you have to part a part of the string, and the element that you're taking should be adjacent to each other, should be neighbors of each other, should be connected to each other. That is the basic idea here. Okay, they are saying one or more substrings. Okay, such that each substring has an even length. Okay, even the substring should have even length. Okay, first thing, and each substring contains only ones or zeros. That is, it should either contain only one or it should either contain only zero. Okay, you can change any characters s from 0 to 1. Okay, return the minimum number of changes required to make the string s as beautiful. Okay, so what is the definition of beautiful string? Okay, the definition is that a string is called beautiful when you can partition it into one or more substrings, and each of the substrings should have these two properties. Okay, what is the first property? It should be of even length. What is the second property? It should be either having only ones or it should be either having only zeros. Okay, so through example I'm trying to you know tell you how it works. Okay, for example, take the string. Okay, here I am, there are eight characters. You can see that like half of them are one and half of them are zero. Okay, now see, try to understand this particular approach, what they're trying to say. I am talking about substrings. Okay, it should, okay, one or more substrings. Okay, and each one of them should have even length. Okay, so if I try to break it down, okay, like what should be the smallest possible substring that I can have? What is the smallest possible length of the substring that I can have, which satisfy this particular property? It should have even length. Okay, so the idea here is this is going to be the smallest possible substring that I can have. Okay, of length 2. Okay, any substring of length 2 is the smallest possible that I can have, because below 2 you cannot have a even length. Okay, that is the first idea here. Okay, so the idea here is this is going to be the smallest possible substring. Okay, other than that, what is the second requirement? They should have only ones or zeros. Okay, if they if they are having it, it's well and good. If they're not having it, we'll have to do some minimum number of changes. Okay, to make string as beautiful. Okay, now try to understand this approach. See here, now if say, let us say I broke it like this. Okay, either you can break it in string of like this, substring of length 2, or you can break it like substring of length 4 in this particular case. Okay, but try to understand here. Can you quickly tell me if each of the substrings of length 2, okay, if they are if they're satisfying this property? Okay, they are even. Obviously they're even because length 2 is even, and they're only having ones and zeros. Okay, they are having only ones and zeros. So in this case, if you see, all the substring of length 2 are having ones and zeros only. Okay, for example, this particular substring, it's a separate, right? Remember, each of them are separate substring. Okay, similarly this is a separate substring, it is having only ones. Similarly, this is having only ones, this is having only zeros, and this is having only zeros. Now when I can break it like this into a substring of length 2 having only equal values, then obviously if I join them, okay, if I join them, I will obviously get a substring which again have same number of values. So the idea here is to break it down. Okay, they have given, right, the string given to us will be of same even length. Okay, what you can do, you have to break it down. Okay, you have to break it down to extent that there are only substrings of length 2 remaining. Okay, first I divided by 2. Okay, then I further divided by 2, and you have to keep doing that until, okay, until you get substrings of length 2. Okay, that is the basic idea. Okay, now the idea here is if I can make this the property, okay, if I can make this particular property satisfied in a substring of length 2, then I can obviously, when I go up the ladder, that is when I join each of the substrings, okay, of length 2, I will obviously get a substring which satisfies this property. Okay, which satisfies this particular property. Are you get, I'm assuming that you are getting my point. Okay, so the idea here is you have to first of all come down to a level where each of the substrings length is 2. Okay, if you can make this property satisfied there, okay, if you can ensure that each of the substring of length 2 have only ones or only zeros, then obviously when you join them, you will get a bigger substring, obviously, which will be satisfying this particular condition. Okay, so what is the conclusion of this question? You have to break the strings into a substring of length 2. Okay, into like, you have to obviously multiple pairs you have to make of each of length 2. Okay, you can call them as substrings of length 2, and then you have to ensure that they have the same value. Okay, either zeros or ones. Okay, as you can see here. Okay, if you have done that, okay, by default you are making the string as beautiful. Okay, as simple as that. So what they're saying, if they're not same, okay, we'll have to make some minimum changes. So we'll see that now. So okay, we will take the first example first. Okay, here is double, okay, double, zero and one. Okay, so what I am doing here, I will try to break it. Okay, this is going to be the example one. Okay, example one. So what I'm doing it, I have to break it, like each time I have to divide by two, and we have to come to extend that where each of the substrings have length two. Okay, so in this case I can get it like this. Okay, 10 and 01. Okay, remember one thing, they are talking about substring and not subsequence. Okay, you cannot take in any order they want. Okay, you have to always take two characters at a time, and that will form the substring. Okay, that will form the substring. Okay, so in this case, what you are seeing, obviously, then all of them. That is, this is the smallest possible substring first of all, right? Which is satisfying this property that it has an even length. Okay, that is the first property. Okay, other than that, what I'm seeing is this particular property is not satisfied. Okay, it is having 10 and 1 1. Okay, but they are not same. Okay, what you have to do, obviously, in this particular thing, I have to do one change. Okay, so in the first substring, I have to do one change. Okay, now talk about the second substring. Here also I need to do one change. Okay, so what are the total number of changes you have to do? You'll have to do two changes here. That is going to be the answer here. Okay, remember, for example, if see, whether I'm going to change the 0 to 1 or 1 to 0, that is up to us. Okay, that is not important here. The question is, what is the minimum number of changes that you have to do? Okay, for example, if I made it 1, okay, if I made it 1, and let us say if I made this 0, whatever you do, that is up to you. But remember, when you join it back, okay, when you join it back, okay, that is going to be 1100, and it is going to be a bit string. Okay, it is going to be a bit string. Okay, that is the basic idea, because it is satisfying these conditions. Okay, because each of the substrings are having only ones and only zeros, and each of the substrings are of length, even length. That is the idea, right? So that is what I'm trying to tell you. Okay, so it was 10 and 01. Okay, so that is what I'm doing here. One change will be needed, and here one change will be needed in this. Okay, and in this, so 1 plus 1 2, and 2 is the answer here. Okay, 2 is the answer here. Now coming to the second question, if you see here, it is already the smallest possible. Okay, here the length is already 2, we cannot divide it further. So the idea here is we have to change either the 0 to 1 or the 1 to 0. That is the only change needed. That's why the answer is 1. Okay, now if you come to this particular question, you will see that all are already zeros. That is, you have to break it. Okay, so this will be the, okay, this will be the first substring. Okay, the first two characters will be the first substring, and the second character will be the second substring, and they are already equal, so you don't have to do anything. So the answer is going to be 0. You see the complexity, that is the, so the probable length of the string, it will be of the range 2 to 10 power 5. Okay, and s will be always even, and it is a binary string, so this particular property is always there. Okay, so now how to solve this question? So as I mentioned, the question looks difficult, but actually it is very, very simple. First, you have to break it down into, a substring of length 2. Okay, that is for each character. You have to pair it with another character which adds into it, and then you have to see if they're same or not. If they're not same, you'll have to do one change. Okay, well, just recalling that number 1. Okay, whether I'm making 0 as 1 or 1 as 0, that is not important in this question. Okay, so if you see here what I'm doing, I'm taking number of changes equal to 0 here. Okay, initially they will be 0. I'm showing the length of the string as n. Okay, then I'm starting, remember, okay, let me zoom in so that you can see better. See here what I'm doing. I'm starting in the first character. Okay, I'm going till n minus 1, and I'm jumping by 2 every time. That is I is equal to I plus 2. Okay, in every case, what I'm doing, see, I'm starting from 1. Okay, then I'll go to 1 to 3, and 3 to 5, 5 to 7, like that. Okay, I'm going to odd in, odd of the indices. What I'm doing, at every character I check whether the ith value is same as the I minus 1th value. Okay, that is, I'm at I, that is, I am at 1, so I'll be checking whether the s of 1 is same as s of 0 or not. Similarly, when I am at s of 3, I will be checking whether s of 3 is same as s of 2 or not. Okay, because see, why I'm doing this, because as I mentioned, I have to check in pairs. Okay, see, I am treating s of I and s of I minus 1 as the pair. Okay, let me write it here. Okay, so the idea here is s of I and s of I minus 1 is going to be my pair. Okay, is going to be my smallest pair. Okay, is a substring. Okay. That is the basic idea here. They should be equal. If they're not equal, I have to make a change in them, and that change I'm trying to record it here. Okay, there is a substring of length. equals to 2. Okay, that is the basic idea, right? So this is the idea that we are following. If they are not equal, then obviously we'll need to make one change here, and that change I'm recording here. I'm just incrementing the number of changes by one. Okay, I will be doing this for all the all the indices. That is, for I will be 1, then 3, then 5, then 7, then 9, like that. Okay, so at every index I will be checking whether I is equal to its previous value or not. That is, s of I is equal to s of I minus 1 or not. Okay, if they're not equal, I need to do one change. Okay, because remember, only when the substring of length 2 is same, only then we can combine multiple such substrings, and make a bigger substring which will be having the same values. That is the basic idea. That is what they're mentioning, right? One or more substrings such that each substring has a length, even length. Okay, and all of them are having the same values. That is the basic idea. Okay, every substring should have same value. All the characters in that substring should have same value. That is the basic idea. So as they mentioned, one or more substrings, so these are going to be our one or more substrings. Okay, and because they mentioned the even length, so satisfying this condition, okay, substring, okay, possible substring, that is smallest possible substring having even length is going to be of length 2. Okay, that's why we are breaking into 2. That's why I'm checking s of I and s of I minus as my smallest possible substring. Okay, and then I'm checking whether equal or not. If they're not equal, I need to do one change here. Okay, as simple as that. And then finally I'm written the change. So if I can run this and show you, okay, you will see that it's clearing all the test cases. I've already submitted this particular solution and it worked. Okay, so friends, yeah, this was the question for today. Though it looks difficult, but basically you have to analyze. Okay, this kind of questions you will probably get in your face-to-face interviews. Okay, and that is the basic idea, because here there is a lot of thinking process involved. There will be some hints given to you to get to this kind of solution, because see, the solution is not very difficult. Okay, it is very, very simple. If you see here, nothing is needed. You just need to know a for loop. That's it, right? But the idea here is how you're imagining that. Okay, you will be getting given some hints. Okay, that why they're when they're saying like this one or more substrings, and substring should have even length, what is the smallest possible substring that we can have. Okay, and then we have to analyze that if the smallest possible substring is satisfying this property, and we're combining such substrings. Okay, for example, this and this, if we are combining such substrings, we will get a bigger substring which is satisfying the property. And that is the idea that we are going to follow. Okay, we're going to dig down to the smallest possible substring which is satisfying which is having even length, and then we are going to check whether they are having same values or not, and if they are not having, we are going to add it by one. So yeah, fun, that was all for today. This question I felt was, yeah, it is worth to be medium, because the kind of question, while seeing it, you may feel that you have to think of some approach, DP approach or greedy approach, something like that, but we'll get to know that, yeah, this is not needed. Just a simple for loop is enough, and we're getting the solution. If you talk about the time complexity, see, the idea here is, if for every n, okay, if for every n, basically we are doing n by 2 comparisons. Okay, because see, I'm going for, yeah, if you see here, the loop that it works, I is jumping for 2 indices, that's I is equal to I plus 2. That is the basic idea, right? So we are actually making n by 2 comparisons here. So but yeah, on the whole it will be O of n solution, and we are not using any space complexity as such, which is related to n. Okay, so space complexity will be constant, so it will be O of 1 space complexity, and the time complexity will be O of n. So it's going to be open. So yeah, fun, that was all for today. If you like my efforts, please do consider subscribing to my channel. And this was all for November, day 5 for the November Daily Code Challenge. See you tomorrow. Thanks a lot.